There are some really good smart RV thermostats on the market. So naturally, we decided to build our own. We wanted something that looked like it belonged in our camper and gave us a little more insight as to how the system is working and can be customized any way we wanted. So we started with a piece of walnut, an ESP32, and a custom circuit board. And of course, a whole lot of late nights. Let's find out if it's actually worth it.
Okay, so we're going to use the CNC router to cut out the face of the thermostat housing. So we're just going to cut this out of a piece of walnut. And we're just going to tape this down with double-sided tape and cut it out. Okay, so we've cut the face out. So now we're going to remove what's left from the router. We got these little tabs that we got to clean up. So we're just going to get them out of there, and then we can sand the rest of them off. Okay, so now we got to knock the radius from the end mill down so the display fits, because right now it doesn't fit in there quite. So we're just going to knock those radiuses down. Just make a square corner. So now, display should fit. We're going to cut some miter joints on this front piece. We're going to use the scrap piece first. I'm going to set this up. This is a little lower than it needs to be. We're going to set it to the right height. So we're going to do a test pass, see how high we need to go, and just keep raising it. Keep raising that up until we get to the very top edge. And we're going to use this fancy coping sled to do this. So as you can see, we still need to take a little bit more off, so we're going to raise it up just a little bit. Still need to do just a tiny bit more. Okay, so we got it done. So as you can see, this is a very sharp corner. There's no flat spot on the top. And it's a perfect 45-degree angle. So now we just got to get the walnut piece and cut all the chamfers on this piece. This is going to be down. So put that in the jig, or the sled, clamp it down and cut it. Okay. Then we'll rotate it 90 degrees. Do the other side. Rotate it another 90 degrees. Do the last side. Now I got 45s on all 4 sides. And that's the top, or the front of the thermostat. Finished. So now we're going to cut the sides. So the first thing when you do, we're not going to be using the coping sled for this because this board's too long. So we're going to drop that bit down. We'll have to set it. We'll make it too low at first so we can test it again. So this is unplugged. I'll just set it up so right here you can see how it's below the top edge of the board. So you want to set it like that. As you can see, got that flat edge there, so we're going to raise the bit up just a little bit. Cut it again. Getting pretty close. Still a tiny flat spot down there, so we'll raise it up just a little bit more. That looks pretty good. Nice sharp corner. So now that that's done, we can cut these sides out of this. So before we cut the sides, we need to cut this to width. So this is going to be 1 3/4 inches. So we'll set that fence. Turn the power on. We'll cut it. Okay, now we got this. So now we can cut the sides. Okay, so to cut the sides, we're gonna do miters. So set our miter saw to 45 degrees. And I like to check this with a digital angle finder. So you put it on the table and zero it. And stick it on the blade. And check that it's 45. See there, that should be close enough. So we'll lock it down. Now we can cut 45s on here. So we'll just do the first one here. Just cut the end off. Plug it in. Okay, so this is about 5 3/8. So we're going to cut the first one to 5 3/8. Okay, so we made a mark at 5 3/8. So we're going to flip this around and cut it there. This is kind of hard to line up, so I like to cut it a little bit bigger and then take little by little off until I get to that line. So you see that was pretty close to the line, so we'll just take a little bit more off. And that should be good. So now we'll cut the other side the same length. close to the line, so we gotta take a little bit more off. That should be good. Check it. Looks pretty good. So now the shorter sides should be 3 3/4. So we're gonna have to cut these 45s off the end here because these are going the wrong way. So I have to cut those off. Flip it around here. Check it. Looks pretty good. So now, this does not look long enough. Because it's not. Okay, so we got another piece cut. So we'll do this again. We just need the last 3 3/4 inch piece now. Flip it around. Take just a little bit more off. Pretty good. So now we can glue this together. Okay, so now we're going to glue it together. So we have a straight edge here. We're going to line up the back sides, not the 45s, the back flat side up against that. There'll be a short one, then a long one, then a short one, and a long one. Keep them up against that straight edge, and we'll use blue tape. We'll tape all the edges there together. And this is a little bit too wide, so just rip it in half. I want to keep it tight up against that straight edge. Let me tape it. Keep that corner tight. I want to kind of push everything together when you tape it. And we're just going to do a test. So we'll fold it all together. And we'll put this in there. Make sure it all looks good. So if it seems to fit pretty good, then we can put some glue on here. And we'll fold it together. Glue on the last edge here. Use a piece of tape. And tape it together. And then we'll get that glue out of there. You can also, to get this glue out, you can wait till it like gels up. Then you can use a chisel to scrape it out of there, but we're just going to wipe it down while it's still wet. You can also use a chisel while it's wet too to kind of get in tight corners. That looks pretty good. So, there's the lid. That fits on there. We're actually going to wait a little bit for this glue to dry before we put the lid on. So we'll just wait like 30 minutes and then we'll put the lid on. Okay, so we're just going to quickly point out this little cutout here is for these little bumps on this side from the soldering. So it just sits in there.
Yeah, so I just to be clear, so we've got the cutout around the edge here for this part of the display, so it sits in here nicely. And then we had it, since they have this, the circuit board extends past that, we have this piece here cut out as well, and drop it in. Yeah, and it fits nice and snug.
Yeah, so I'll set that aside and we can glue this cover on. Try to get it as even as possible here. You don't want to push one side down and have the other side pop out. That's all clamped. We'll wipe that glue off. All the squeeze out. All right, now we wait.
Okay, Kevin has the box done, so I'm just going to go over real briefly the control circuits, and then we'll put this thing together, throw it in the RV, and see if it works. We have relays here. These are going to control the heat, AC, and then the fans. This is the microcontroller. This is an ESP32 Arduino. That handles all the control. And then this other piece I wanted to show you is this is a presence sensor. I added that, the parent you're trying to build against, they have it shuts the screen off after there's a certain amount of inactivity, and then you just touch the screen to have it come back on. With this presence sensor, mine, it works very similar. The only difference is you have to touch it as soon as you walk in front of the thermostat, it'll turn the display on. So I'm going to go ahead and I'm going to assemble this, and then we'll bring it out to the RV and run a test. One thing we didn't mention that I'm going to go ahead and mention now is, look on the top. We added these vents. We didn't show you actually us creating those. Those are necessary, and there's actually the same thing on the bottom. We need airflow across the sensor, which I don't know if you can see, that's that metal tab that we have the sensor in. Without the airflow, of course, you're going to measure the inside of the thermostat, which is not helpful. So we added the vent holes on both sides to get airflow across the sensor. I'm going to go over the functionality real quickly. On the top here, you can see we have a standard thermostat controls. I can increase the set point, decrease set point, cool, heat, fan. I'll just turn the fan on, as you can see. So the fan is not, when the fan is in auto mode, when it's running or when it's cooling, you'll have the fan will just start automatically. And the way it's set up is, if you're really close to the set point, it's going to have the fan in low. If it's closer, it'll turn the fan on. Or sorry, if it's farther away from the set point, it'll have the fan running on high. Otherwise, you can set it manually to run high or low. So that's very straightforward. They're pretty much standard functionality for a thermostat. Then I have the weather down here, sunset, sunrise, of course the temperature outside. And then we have this little indicator icon. We have a few of those, and I'll show you those later, but this is just saying, of course, it's a beautiful sunny day. So I will show you the rest of the settings. Okay, so since this is connecting to Wi-Fi, standard, set up your Wi-Fi configuration, password, network name, and then I have this button here. If you change the network for some reason, the reconnect is one of the two things. If you've changed it, or the way it's set up is it'll only attempt to connect, I think it's 5 times. If it fails after that, it just gives up, and then it's, of course, you're running as a standard, not a smart, I guess, or you can't control it from your phone or anything like that. So if that happens, you'd have to fix your settings and then just tell it to reconnect. The calibrate touch, just so you can configure the screen. Pretty much once you set it, is done. But I added this when I was building the app, so it was easy for me to kind of calibrate all the button locations. And then this web external. By default, when this thing with the code the way I have it is it's running, and I'm going to go ahead and jump to that so I can explain this better. You can see it's really small, but I put the IP address of once we've connected to the Wi-Fi. If you connect to that IP address, it's going to give you the same the web form, which I'll show later. That's how you, it's just the website, and that's how you can control the app from your phone or your computer, or control the temperature. So that's what, so that with the web external off, it's going to be running from your local, this thermostat's going to be hosting the website. If you enable external, let me just jump back to that. If this was on, it's gonna, same type thing you can control from your phone or your desktop. The difference is where the website is hosted, and in this case, my setup, it's hosted on Cloudflare. And they have a very cheap, actually a very generous free setup. So with that, it's a little more secure. Just because localhost, of course, especially if you're using a shared Wi-Fi, anybody that's connected to that Wi-Fi and happen to cross that IP address, they could control the temperature of your RV. Not a huge risk, granted. I don't think a lot of people would want to mess with that, but it is less secure. We do have, let me just jump to that. This device is set up if you are using the Wi-Fi. Basically, you have to add your device, and this changes every time. So even if somebody had connected to your Wi-Fi, if their device wasn't added, they wouldn't be able to control it, even if you shared the Wi-Fi. However, it's not a secure website, so anybody that knew what they're doing could get past that, and they could still control your thermostat. So again, it not a huge risk. I don't think a lot of people are going to be messing with your thermostat. Two ways to get around that. One, if you're connecting this to your own hotspot or whatever, that's going to be enough security. It's very difficult for someone to get bypass that unless you have a poor setup. The alternative is the external, and I have instructions for all this. If you want to set up your own external, just take a look at the links below, and it walks you through how to set up your own Cloudflare website. And it'll be secure, and again, you still have to have the device added. So you come here, add your devices, and again, if you don't have your device added, you can still see the temperature, but you wouldn't be able to control anything. So anyway, so that's what that external is for. And again, so you can basically control the thermostat from your phone or your desktop or your laptop. So since I'm on this page here, this is one of the features we added that the competitive, or some of the ones on the market, don't have. I added hour meters. You can see, so since we were on the trip last weekend, we ran the air conditioner about 13 hours and 48 minutes. So which is actually pretty good considering there was absolutely no shade where we're at. And it was very hot, so that's actually not as bad as I thought. So that's the actual runtime of the air conditioner. And then down below here, a little bit difficult to see, but I added these two set other gauges, I guess. So time to reach set point. So if we'd set it, for example, when we first got to the site, the camper's probably 80 degrees or 90 degrees. So this is going to track from whatever set point you set. How long did it take to get there? In this case, the average was 42 minutes. And then the second setting here is how long it took to change 1 degree. So this one, it took 8 minutes for it to change 1 degree. I don't know if that's good or bad for an average. It's the first time I've tried that. Like I said, we weren't doing zero shade, and it was very hot, so that might be reasonable. Anyway, it's kind of interesting, and it might give us some indication if things are failing, if these numbers stay fairly consistent, assuming the same temperature and zero shade. And then suddenly it changes quite a bit, and it's taking 20 minutes to move a degree. May indicate that maybe need to take a look at servicing our air conditioner. But if not, it's kind of cool information. The other thing I will mention on this screen, I don't have it here now, and I could probably fire it up. But one thing is, if you turn on the air conditioner, and I think you can hear that started now. One of the things you have to do, you can't, if I was to shut this off, so I'm gonna go ahead and shut it off. you don't want to restart it right away. You basically want the pressure in the lines to equalize before you start it again. And I'm sure all thermostats have this built-in functionality, but if I was to start it again and I was trying to figure out why it wasn't running, I just added this timer so you can kind of see. This is showing how much time before it'll actually let you start it again. So basically, I think it's a 2-minute timer that gives the AC time for the pressure to equalize before it'll start turning again. So that's that, and I think that covers. Oh, never mind. There's a couple more things we've got. So if I go to System Info, oh, wrong one. There we go. So this is the icons I mentioned before. We have just a very simple guide. Kind of silly, but you know, hey, we want to have fun with this too, right? So if it's really, really hot out, we give you the Melty Face icon. Beautiful day, you know, you get the center sunshine, sunny, beautiful day. Then we have the icon for just a cool day, so it's kind of throw a sweatshirt on, go have some fun. Snowflake, it's cold out, you might want to dress a little warmer. And then freezy face, nope, just stay inside. And of course our competition doesn't have that, so that's that. I think that covers all the functionality. So again, it's a fairly straightforward, standard thermostat, but it's a smart one. So I don't have to be standing right here if I want to change the temp or change the settings inside. I can do it from my bedroom or sitting around the fire. So the question, of course, is, was this worth it? Build versus buy, right? Personally, I think it was. From a cost perspective, this was a little bit cheaper than buying one off the shelf. From a time perspective, of course, I think we have about 25 hours worth of coding time. Somewhere in the same range for probably more like 8 hours for the circuit design. It's a fairly simple circuit. And then, of course, the build for the box. That took some time. So time-wise, obviously, is a much more bigger investment, but in the end, we got what we wanted, exactly what we wanted. So I think it was worth it, but you guys let us know what you think. Just one quick note, we have all these schematics and everything will be shared in the links below if you want to build one of these yourself.